Here are the confidence interval and hypothesis test formulas when estimating the difference between two means. We can see how similar it is to estimating a single mean, right? When we estimated a single mean, we took our sample mean and we added and subtracted a certain number of standard errors. We're going to be doing the same thing, but now we're going to be looking at the difference between two sample means. We'll add and subtract a certain number of standard errors. Now, the standard error notation you see here is just representing that this standard error, x bar 1 minus x bar 2, is going to be a different standard error than when you estimate a single mean. So this isn't to say plug the sample mean values in there. It's just notation. It's saying those two standard errors are going to be different. For a hypothesis test, again, it works the same exact way. We look at a sample mean. We see how different it is from a population mean, some assumed value, in terms of standard errors. So you can see the format is essentially exactly the same. Instead of a single mean, we're looking at the difference between two means. What we'll find here, though, is typically in statistics, we're going to be interested in setting mu1 minus mu2 equal to 0. Because in doing so, that's going to represent that they're the same value. We're going to assume mu1 and mu2 is the same in hopes of trying to prove that there's a difference. Let's look at our hypotheses and see why that's typically what we do. Set mu1 minus mu2 equal to 0 for hypothesis tests. We can write our hypotheses one of two ways. We can write it in terms of the difference between two means, or we can write it in terms of the comparison of two means. So our null hypothesis will typically be mu1 minus mu2 equals 0, or mu1 equals mu2. They're representing the same exact thing. However, I think it will be beneficial for us to think about hypotheses in terms of the difference between two means. When we learn about different types of data, it will be beneficial for us to think about things in terms of differences as opposed to comparing them independently. So while it's not wrong to write your hypotheses as mu1 equals mu2, you can definitely do that. I think it's better for us to think about things in terms of the differences. Now, here's why we are typically interested in having your two means be exactly the same as your null hypothesis, mu1 minus mu2 equals 0. Suppose that our hypothesis was mu1 minus mu2 equals 5. This would imply, and what we're assuming here, is that mu1 is 5 units bigger than mu2. But suppose somebody said, well, hey, wait a second. I don't think that's the case. I think that this quantity is less than 5. Suppose at the end of our statistical test, we found evidence, and that evidence yielded us the result to reject the null and to support HA. We had evidence to reject our null and support HA. What this would be saying is the quantity mu1 minus mu2 is less than 5. Well, being less than 5 can result in a value of 4, of 1. Both of those would be saying that mu1 is bigger. 0, they're saying they're exactly the same. -3, mu2 is bigger. Being less than 5 can result in any one of these possibilities. Maybe mu1 is bigger, maybe they're exactly the same, or maybe mu2 is bigger. We haven't learned about which mean is bigger. This is why we typically don't set that hypothesized value to something other than 0. Because if we support HA here, we actually haven't learned about which one is bigger or which one is smaller. This is why for our class, we'll mostly be interested in setting this hypothesized value to 0.